AQA Required Practical Titration Technique. So let's name some of the glassware. Stop the lesson. Can you name these 1, 2, 3 items? Speak them out. Okay, so burette, volumetric pipette, measuring cylinder. Now, what would be the advantages of a burette over a volumetric pipette and of a volumetric pipette over a measuring cylinder? Compare the advantages and disadvantages of each instrument. Stop the lesson, think it through, write down some ideas, come back to check. Okay, so if we compare a burette and a volumetric pipette, then the burette measures any volume of solution. The pipette measures one volume of solution. If we compare the volumetric pipette to the measuring cylinder, what's an advantage of a measuring cylinder? Well, it's much quicker, but the volumetric pipette is more accurate. So here are 3 further items of titration equipment. Can you name them? Conical flask. This is a distilled water bottle or wash bottle. Now, please note, all glassware must be rinsed with distilled water before use. Often a question. This is a white tile. The purpose of a white tile would be, well, you place it underneath the conical flask to improve the clarity of colour changes. So let's get into some titration technique. The first step is to carry out the washing routines. So for the burette and volumetric pipette, the first thing to do is to rinse with distilled water, as mentioned on the previous slide. That is to remove impurities. Then rinse with the test solution. We need to remove any distilled water that remains in or on the glassware. So rinse with distilled water, removing impurities, then getting rid of any excess distilled water by rinsing with the test solution. Our conical flask also needs to be rinsed with distilled water, but there's no further rinsing with the test solution. The burette and volumetric pipette are measuring quantities of solution. The conical flask is receiving a measured volume. Therefore, it mustn't contain any of that solution itself. However, it does need rinsing with distilled water to get rid of impurities. So having prepared your solution in a volumetric flask, we now need to extract 25 centimeters cubed, the usual volume. You may need a different volume, using a volumetric pipette. So here is our volumetric pipette with pipette filler. I have a traditional image there. You may have a more modern one to use in your laboratory. I hope so. The procedure before you use the pipette is to rinse the pipette with tap water, distilled water, and then a little of the solution that is to fill the pipette. So that's the same procedure as for rinsing the burette. Now, having inserted the pipette into your volumetric flask, you'll notice that there is a graduation mark at the volume printed on the pipette. In this case, I'm assuming it is 25 centimeters cubed. So we're going to fill the pipette up to the graduation mark on the pipette. Obviously, bottom of the meniscus as previously. Having filled the pipette to the graduation mark, you then obviously remove from the standard flask and transferring a short distance to a conical flask, a clean conical flask. make sure that the conical flask is close to your volumetric flask and you're not transferring that any distance, because we don't want any drops or any loss of solution from the pipette. So my recommendation is that you remove the pipette filler and allow the pipette to drain. Touch the surface of the solution with the pipette and allow the pipette to drain for 10 seconds after it appears to have been completed. You will then see that there is a small volume remaining in the pipette. That is meant to be there. That is part of the design. So the pipette delivers 25 centimeters cubed from the graduation mark to the tip of the pipette, but the small amount of solution held in the pipette is taken into account in measuring that volume. So your pipette, when empty, should have a small amount of solution in the tip. So we have 25 centimeters cubed of a solution of known concentration in the conical flask. We now need to prepare our burette and the burette solution. So the process for preparing the burette is the same as for the volumetric pipette. That is, you rinse the burette with tap water, then with distilled water, then with a little of the solution. We fill the burette from a beaker with shall we say, the solution of unknown concentration. And of course, we need to make sure that the tap of the burette is closed, which is in the position as indicated. We also note that we have a beaker underneath the burette. We do not place the conical flask under the burette at this point because there may be spillage in this part. You often, when you're inexperienced, overfill the funnel and then you have solution running down the burette. So we don't want that going into the conical flask of our test solution. So a beaker to catch any overflow. So here is a burette ready to be used with the solution. That's now been transferred to beneath the burette. There are 3 errors in the setup of this burette. I'd like you to pause the lesson and look carefully at the burette. What are the 3 errors? Come back when you're ready to discuss further. Okay, so I can help the situation by a diagram of the burette in the correct setup. And you'll notice there are 3 distinct differences. Firstly, the filter funnel, or the burette funnel has been removed. The burette funnel often has the potential to drip into the burette during a measurement, which is obviously not desirable. So the burette funnel needs to be removed. You'll notice also a difference here and here. If you look very closely, we must fill below the tap. And finally, the position of the burette tip is within the shaped part of the conical flask. The conical flask is shaped as it is to allow the burette funnel into its mouth. So in this arrangement here, on the left-hand side, we can see there's the potential for spillage. There's no such potential on the right-hand version. So it's the right-hand version that is correct. So we then, having noted the initial volume, we add some indicator, and generally we'll see that there's a colour change, and at the colour change point we stop the titration and we take the final volume. So the volume delivered by the burette is the difference between the initial and the final, and that is called the titer. Let's practice a few burette readings. Here's an initial volume, and here's a final volume, another initial and another final. Looking at those, write down the volumes, the 4 volumes that are present in the burette. Come back to check against mine when you are ready. Okay, so restarting, 0.60, 18.30, 9.20 and 21.00. We are always recording volumes either to 0.00, that's to 2 decimal places. The second decimal place is either a 0 or a 5. So the degree of precision that we can use in a burette is half the smallest graduation mark. So we're 0.1 centimeters cubed marked out on the scale, so we can read to half of that. So all your readings must be either, or must be 2 decimal places, the second decimal place being 0 or 0.5. So the volume at which the indicator changes colour indicates when we have mixed together exactly reacting quantities of acid and alkali, and we call that the indicator endpoint. Now here's a table of data. Normally we list the final volume above the initial volume and therefore simply calculate the difference between the two, which is the titer. So I imagine I've got an initial volume of 0.55, a final of 18.25 gives me a volume delivered, a titer 17.7. But titrations are repeated to increase the reliability of the data. So titration 2, starting with 18.25, final volume 30.4, gives me a calculated titer of 12.15. These two numbers are not in agreement, they are not concordant. We need to do a third titration, which gives a titer of 17.8. Now 17.7 and 17.8 are in agreement, they are concordant. We discard the anomalous titer, which is this one here, and we average titers that agree. So we average 17.7 and 17.8, add them together and divide by 2. So our reliable titer is 17.75 centimeters cubed. I hope you found that helpful. If you did, please recommend to a friend. Please like. Thanks very much. Bye.